Assalamualaikum warahmatullahi wabarakatuh. I'm NURDINI BATRISYIA, BINTI BADRUL from DNM5E, and our presentation is about how air transport pollution contribute to global. As far as we know, flight consume a lot of energy and rely on fossil fuels. Fuel tax incentives give the airline industry an enormous advantage over the modes of transportation. Since low flight costs do not reflect their impact on the environment, consumers are unaware of the true environmental cost of their air travel. Flight emissions stay in the atmosphere and will continue to warm it for centuries. As we can see, pollution from air transport produce more than just CO2 that makes climate impact on our planet. It makes the earth become hotter due to propulsion that contribute to global warming. Since aircraft emissions are high in the atmosphere, they have a significant impact on climate change, which make the chemical reaction and the atmosphere's effect that increase the temperature of our planet.
So today we would like to present about global CO2 emission and fuel efficiency. So let me start first this presentation with how the air transport contribute to global CO2 emission. First and foremost, I would like to explain about CO2 emission. So the definition of CO2 emission is the amount of carbon dioxide that have been stemming from the burning of fossil fuel. The carbon dioxide, which is CO2, is a colorless, odorless, and non-poisonous gas formed by combustions of carbon and is considered as a greenhouse gas. The emission means the release of the greenhouse gas into the atmosphere over a specific area and period of time. The gases that trap heat in the atmosphere are called greenhouse gases. So today, we can see that airline account around 3.5% of all emission contribution to climate change. So according to a study in the journal Atmospheric Environment, the transportation sector is the largest emitter of greenhouse gases. And back to the regarding to the topic, which is how the air transport can contribute to global CO2 emission. So the aircraft or airplane will run on the kerosene fuel, which is it will burn, emit a large amount of carbon dioxide and other gases into the atmosphere, and it will give a significant impact on the climate system, seems like greenhouse impact. So when all of these gases are combined with CO2 emission that produced by aeroplane, the percentage quickly rise to roughly 5%. So next slide is we can see that the pie chart talk about the percentage of which sector are contribute more in the CO2 emission. So here we can see that the transportation has the largest percentage, which is 29% compared to the other sector. So let's move on to the topic, which is the way on how to promote the airline fuel efficiency. So the first one is by hydraulic engines can be replaced with the electric engine. To deal with the problem of climate impact by the aviation industry, the technology can be used in the design and system of plane to make them more efficient. A breakthrough in the use of another type of fuel that is greener, electric engine, solar panel, and batteries. It could save the world from the degradation of the environment by aircraft engine running on kerosene. The next one is by improving the air traffic management. The control of air traffic can be optimized so that any plane can avoid waiting at the airport before departure or in the air before landing. The entire airspace can be used better so that the plane do not have to crisscross around the forbidden zone. So we can legislate to reduce CO2 emission from aviation, but it must happen in the global agreement in order not to distort competition. So the third one is we can having a new aircraft. So we can see that each new generation of aircraft burn roughly around 15% less fuel per passenger kilometer that the aircraft is replaced. So here I want to say that the key technologies include more fuel efficient engine can improve by improve the aerodynamic, lightweight material, and also advanced system. With the new aircraft, it will definitely come with the advanced technology that suitable technology to be used in overcoming the problem of global emission and more towards eco-friendly. And last but not least, we can improve the efficiency by improving the operation. Airline can improve fuel efficiency by increasing flight payloads and flying more directly to destination. In addition to purchasing new aircraft, payload can be raised by filling a given capacity more efficiently or by raising capacity. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Zulirfan. So today I want to present about operation and regulatory constraint. First is operational. Congestion and extra fuel consumption are caused by a lack of airport and taxi facilities. As we know, there are some countries that have one or two international airports. So the other country want to deliver the item, they need to transit at the international airport and get to their destination. Next is because to military zones and other government constraints, rules are flown less directly. There are some zones in the world that dangerous for the air transport to fly on, so they need to get to the destination using longer route. Next is regulation. Bilateral agreement between two countries they govern air transportation. There are some air transportation company that the government hold. So if there are no political connection, they will not go to the country. And lastly, operating on a completely bilateral basis would drastically restrict the route average load factor. If the two connections have the contract, so they will make the regulation themselves. So if the regulation make the average load low, so it will make the often flying to the same country to get to the destination. That's all. Thank you.
This is the future global of CO2 scenarios. The US Energy Information Administration projects that changes in energy-related carbon dioxide, which is CO2 emissions over time, will indicate the predicted shift in fuel usage and energy mix in the annual energy Outlook 2021 reference case. Carbon dioxide emissions are expected to fall from 2023 to 2035 as a result of the shift away from more political and increase in use of natural gas and renewable energy. After 2035, CO2 emissions in the United States begin to rise, reflecting the overall increase in energy consumption as a result of rising population and economic growth. We can see more in the data from annual energy outlook from US Energy Information Administration. As we can see from the data by the EIA, total US electricity CO2 emissions in 2050 will be around 4,507 million tons, or about 5% more in 2020. The AEO 2021 reference tends to assume that latest rules and regulations affecting the energy industry and those with expiration dates will stay static throughout the projected timeframe. Next, the International Energy Outlook 2021 reference case forecasts that if current legislation and technology current trend continues, the world energy consumption and electricity of CO2 emission will rise from 2022 to 2050 because of the population and economic growth. Nevertheless, predicted future growth in energy power related CO2 emissions is not equally distributed worldwide, with the most of the projected future growth in energy related CO2 emissions occurring in nations that are not members of the Organization for Economic Cooperation and Development.
Bismillahirrahmanirrahim. My name is Muhammad Shafi Naim bin WASRI with ID number PDL2007-106. Alright, now I would like to present about the investment in greater fuel efficiency for the future. Alright, firstly, what is fuel efficiency? Fuel efficiency is a form of thermal efficiency, meaning that the ratio of effort to result of a process that converts chemical potential energy contained in fuel into kinetic energy. Fuel efficiency has important environmental benefits too. Fuel efficiency will burn less fuel than others. First, given the high price of oil, airlines can save considerable sums of money by using less fuel through improved fuel efficiency. Secondly, if an airplane uses less fuel, it will produce lower carbon dioxide emissions. So, there are 3 ways on how to increase fuel efficiency. The first is optimizing engine operation. The most important aspect of engine operation is to ensure that the engine is in good condition and all adjustments are accurate. The first item is timing and magnetic operation. If the timing is retarded, you will lose a significant amount of efficiency. If you have a fall plug, the cylinder may still be fired by the second spark plug, but the fall spark plug will effectively retard the timing and reduce fuel economy. The second is improve aerodynamic. Aerodynamic drag is mainly ensuring such things as proper door gaps. Other possibilities are wheel pans that can smooth out your aerodynamic posture, and of course speed is the biggest consideration. As we know, we fly to get someplace quickly, but running at lower power will reduce fuel burn significantly than higher power. The third is improving operation parameters. Finally, there is operation techniques. I have mentioned speed, but there is also reduced idle time, flying at constant speed and altitude, plus other items. But the big factor here is leaning. Leaning can offer the biggest improvement, but also offers the biggest risk. But this results in maximum combustion temperature and can lead to a burnt cylinder assembly. So, it can also improve the fuel efficiency by burn the fuel with better combustion. That's all from me.
Next, I would like to present about the e-cargo network and industry fuel efficiency. First, let's see about what is meant by e-cargo network. E-cargo network, ACN, or Air Transportation Network, ATN, is meant by the type of transport and special network. Here we can say that ACN is the network of geographical. Next, reflect direct flight routes between two airports. The airport are the nearest nodes, so the connection indicate direct flight routes between them. Next, indicating direct A connection. Here, cities can also be thought as nodes that links indicating direct A connection between them. And last, network scale might be global or domestic. It's mean like a transport network can be designed as globally, regionally, or for a single airline business. So here, the network scope might be global or domestic. Okay, now we go to how the air cargo network achieve fuel efficiency. Okay, first, offer a network of flights focused on one or more hubs by gives one-stop service to a large number of markets. So this is relevant to both passenger and cargo aircraft services. Okay, then we go to the hub. Okay, first passenger hub. They often served by feeder services with small aircraft. Okay, this is because there are convenient connections are provided to other short haul and long haul flights. And for cargo hubs, tend to be fed by shorter haul truck services rather than flights. This because operating trucks has the lower unit cost, so it will decrease the sensitivity of time of cargo generally. So for the last point, they prefer hub airports, they are not passenger hubs, to have less clutter. Okay, for example, air cargo traffic is carried by the combination carriers that also carry passengers. Okay, such as cargo labs as cargo specialists, and then we see FedEx, UPS, the NT, and DHL as the integrators. So this will reduce the environmental impacts from stacking and have long aircraft taxi times. So for this slide, as you can see, there are three types of transport, which are there are two aircraft and one truck. So they use B747-400F and MD-11F aircraft and combine with this truck to have the efficiency fuel, so that by operate the hub by trucks and flying the long haul sectors, they can operate and be able to increase the fuel efficiency. From this topic, air transport pollution's contribution to global, we can conclude that air transport clearly give effect to the global, such as the carbon dioxide that give bad effect to the environment. But however, they still can manage the pollution by control the usage of fuel efficiently. That's all from us. Thank you.